Hello and welcome to the session, and let's continue our discussion for polymorphism. Polymorphism is basically many forms, polymorphism. So let's look at this picture first. So if you see here, there is a basic car sketch, basic model that is there, and there are multiple implementations or multiple ways of implementing that car. Okay, same example here for mobile. So we have a basic model here, basic sketch or basic class, and I can implement it, and I can use it in a different way what I want. So I can have a different design, let's say different color. So the way I want to implement, the way I want to use the buttons and all, the way the cameras are functioning, that is all dependent. So I can still take the picture, I can still turn on the mobile, but in a different way. Similarly, so what is a polymorphism? It is a concept by which we can perform a single action in multiple ways or in many forms. It is the capability of a method to perform in multiple ways based on what and how arguments are passed to it. So it is slightly dependent on the arguments what we pass. Now there are two types here, compile time and runtime. And runtime also, it is using class and using interface. Now, compile time is also called as method overloading, and runtime polymorphism is also called as method overriding. So let's see an example and things will be much clear with an example. So I have this class, I have this package compile time package 20. Here I have this class called as bank account. Now in the bank account class, if you see, now there's a method called as open account. There's a method called as open account. There's a method called as open account. So I have the same method name here, and here if you see, there is zero argument, there is one integer argument, and there is one string argument. So in some of the situations where I want to use the same method name but different parameter or argument list I want to pass to it, so that is basically is called as a polymorphism, and this is a compile time polymorphism. So polymorphism means we can use the same method and with a different ways, multiple ways we can call the method. So what is the multiple ways? Empty parameter, integer one parameter, or string parameter, or multiple parameters. So let's see. So let's see the discussion. Compile time or method overloading. Same method name, but with different type or sequence of parameters. So different type of parameters or different sequence of parameters. So we have seen in the example where there is no parameter, one integer parameter, one string parameter. No parameter, one integer. So the parameters are a bit different, but method name is same. Okay. Compiler. So why it is called as compile time polymorphism or method overloading? So basically whenever you design the class which is compile time polymorphism, that means you have the same method name but different set of arguments. So compiler, when it is compiling the class, that time it knows about what is the polymorphism will be done, so it will make a corresponding bytecode. So that is why it is called as compile time polymorphism, because at the time of compilation, compiler knows that there are different methods which there are same methods. There are methods which is having the same method name but different parameters. Now when overloaded method is called, then Java uses the type or number of arguments to determine which exact method to be called. Let's see with an example. Let's say method vehicle driving. This is also compile time polymorphism. Now if you see here, there is no parameter, there is one integer parameter, there is one integer and one string. So number of parameters are different, the sequence is different or the type is different. Here also if you see, there is one parameter, there is one parameter, but it is of different type. So what is the catch here is, in the compile time polymorphism we should have different parameters, okay, or the sequence should be different and so on, right? So when overloaded method is called, so now how this which method to be called, runtime, how it is decided. So whenever you compile and run this class, whenever let's say I'm calling drive vehicle, or I'm calling with one argument, or I'm calling with two argument. So whenever the bytecode is ready, and whenever JVM runs the bytecode, and whenever it encounters that there is a method with the same name, but then there are multiple methods defined here, so which exactly method to be called here, so it will decide based on the number of arguments here. Okay, if you see here, when this is invoked, that is matching to this definition where there are no arguments. When this is invoked, it is matching to one integer parameter. So there is a matching method with one integer. Now in the second case, there is one integer and one string. So this is also possible. So this is basically called as compile time polymorphism. Let's run it. Right, so driving hands-free, motorcycle with helmet, and sports mode. That is what we are doing here with calling multiple methods in compile time polymorphism. So what are the things which makes the methods as overloaded methods, or what makes it as a compile time polymorphism is basically different number of arguments in the argument list. So argument total should be different. Second thing is difference in type of parameters. So let's say you have two methods. Let's see with an example. Now I have one more method here which takes two arguments, one integer and one string. Okay, but what I'm doing, I'm just changing the sequence here. So this is also allowed. This is also allowed. Why? Because the method takes two arguments, but the syntax is different. That is why this is also allowed. So difference in type of parameters and sequence of data types of arguments. So integer, string, string, integer, and so on. So either of these three is matching, then the methods are called as overloaded methods, or we can refer to it as a compile time polymorphism. Now there might be questions like, does method return type matter in case of overloading? So if you see here, return type, so here there is void return type, here there is int return type, here there is also int return type. So those two methods are returning integer as return type, but if you see the arguments are different. So return type does not matter when you are dealing with compile time polymorphism. Okay, can we overload main method? I think this we have seen in the earlier sessions also. Yes, we can overload the main method by just changing the number of arguments or adding another set of argument. So let us see. So this is a main method. So what I will do, I will add one more main method here and just let it be little empty. And here what I'm saying, instead of instead of one argument, I will say int k. So this way I can overload the main method. Okay, there's a main method which is having string array argument. There's a main method which is having string array and integer, or let's say only integer. So this is also allowed. I can overload the main method, but the as per the rule, when this class is loaded into the memory in the JVM, looks for the method which is having exactly this signature. Okay, so even if there are two main methods, the JVM will look for only this particular signature and it will run the main class. Okay, now let us see. Now if you see right click, I am getting an option of run. Now what I will do, I will just comment this out. I will just save it. And now if I right click, you see there is no option to run. Why? Because there is no exact method which matches the particular signature, and that is why it will not run. But technically speaking, you can have you can overload the main method. Can I overload a constructor? So I think this we have done in the constructor session. We can overload constructor also, basically having different set of parameters. So any of this criteria is matching for constructor, we can overload a constructor also. Okay, now let us see runtime polymorphism, or also called as method overriding. This is slightly different. So here, when what happens is, there are methods. It is basically a parent child concept. So parent has a method, let's say ABC, and child has the method. So what child wants is, child wants to extend the parent class, but in the parent class the child wants to have a different implementation of the method which is in the parent class. Okay, we will see with an example. So uh, a feature that allows a child class to provide a specific implementation of a method that is already provided by one of its parent classes or maybe interfaces. Okay, so child wants to have a different implementation in its own class. That is why it is runtime polymorphism or method overriding. Child class method signature should be similar to the parent class method, that is argument list and sequence. Let's see with an example. Now there's a method called as bank. There's a class called as bank and bank city. Now you see here there's just a basic bank here where they are processing the transactions, and there is certain implementation, and there's a integer variable here, right? Now Citibank, it extends the bank, right? But the process transaction section, process transaction method is basically overridden. Overridden means the child class wants to have little different implementation. Little different means it can be the same but slightly changed or totally different. That is why when I say override, that means it is overriding this process transaction method from the parent class. Now let us see what is different here. So if you see, if you just compare here, if you see in the Citibank, it is saying that balance is going negative, so this transaction is failed, and they are doing this balance calculation extra. Okay, whereas that is not done in the in the original class or in the parent class. Also in the credit, when they are doing credit transaction processing, which is of type credit, they are just adding amount here. But in the Citibank, what they are doing, they are checking whether the amount is, let's say, more than 100,000. If the amount is more than 100,000, that they're saying that okay, target this user for some promotional offers or something. So that is a different implementation or slightly different implementation. So what I'm doing, how to override this, how to change the implementation, you just say override the method which is there in the parent, and you provide the specific implementation. So this is basically method overriding. Okay, and I can call the methods, and I can do different type of C. So if you see in this case, I am processing 100,000 transaction. So in this case, it will print target this CT user for 100,000. So for promo offer, let's just run it. Right, so it is saying target this user for promo offer because it is the balance is, the credit amount is more than 100,000 and so on. Okay, so child class method signature should be similar to the parent class method, that is argument list and sequence. So this is important. What is happening here is basically what we are doing is we are giving a different implementation of to a method which is there in the parent class. So the signature of the child class method should be exactly similar. Okay, with a slight changes there, but it should be exactly same. So number of arguments, method name, those things should be exactly same. Now, why it is called as runtime polymorphism? Okay, so interesting question. So what happens is, now if you see, this is a basically parent-child concept. Okay, parent-child concept. So the compilation of this class and the compilation of this class, bytecode generations happens separately. Now at the time of compilation of this class compiler doesn't know that this class it will be extended in some other class. So basically what the compilation will be done separately. Now in this case, though it is extends keyword, though it is written as override, but there is some method here. So this method and the earlier method will not be linked. Okay, they will be linked, or runtime, when the process transaction method will be called by object of this class, that time the linking happens to the process transaction method from this class only, and that is using override. So this happens at runtime. That is why it is called as runtime polymorphism, because compiler does not know about polymorphism during the compilation, rather it happens at runtime. So method linking and referring to the parent class entity, parent class variable or method, that happens at runtime. That is why it is called as runtime polymorphism. Now there can be questions. Uh, does method return type matter in case of overloading? Okay, so if you see here, in case of overloading, this is not overriding question. So yes, it is the earlier question, does method return type matter in case of overloading? And in this case, does method return type matter in case of overloading? No, in case of overloading it does not matter. Is it possible to override parent class variable? Okay, interesting question. Now if you see here, override, right? So this override is basically written for any method. Okay, if you see here in this class, here there is a variable. Okay, so the question is, can I override this method, this variable inside the child class? Okay, like this. So, and can I use this override keyword? So override keyword is normally not used for a variable. Okay, rather, in other words, you cannot override the variable which is present in the parent class. Overriding is only allowed for methods, not for the variables. Okay, so let us see the difference between compile time polymorphism and runtime polymorphism. And this is probably the top 5 question in an interview for any level: senior level, junior level, lead level, or management level. Now, compile time polymorphism and runtime polymorphism. Now, one thing we just missed here is using the uh, interface. So what is an interface? That we'll be discussing in subsequent section, but for now, consider interface is something where you just have the body or signature of the method, but there is no body. Okay, if you see here, this method is just an empty method. Okay, there is no body to this. This is basically called as interface. Now, employee hiring and engineering, and employee hiring marketing. Now now this class interface has basically two methods: provide skill and hire employee. Now here, what is happening in this class, I'm implementing the interface. Here also I'm implementing the interface, but I am overriding the method which is in the interface, and I am providing the implementation. Okay, so if you see here, provide skills and hire employee, I'm providing some implementation. I'm providing a body to that method. Okay, if you see here, there is no body, there is no implementation. So here I have implemented that. I have implemented that. Now, of course, for engineering employee, the skills required will be different. For marketing employee, the skills required will be different. So what I'm doing, I'm creating an object here of this employee hiring engineering, and I'm providing the skills. Let's say for engineering employee, products design, programming, UI design, and so on. And I'm saying hire 5 employee, that is vacancy. In the marketing section, of course, the skills will be different: telemarketing, outbound calling, multi-language communication, and so on. And there are currently 3 openings. So this is how the runtime polymorphism happens for interface example. Earlier example for bank and Citibank, that is class to class. Here it is interface to class. Okay, here it is interface to class. If you see here, we can do runtime polymorphism for an interface also, but this is basically class to class. This is basically interface to class. Right, so difference. So compile time or run and runtime, this happens within the same class. This happens between parent and child class. Why? Because in the runtime polymorphism, we are overriding the methods which are in the parent class. So that is basically between parent and child. Method argument type and sequence should not be same here in this case, and it should be, sequence should be same, right? So what we are doing is we are just implementing the method in another way. So that means the argument list should be exactly same. May have different return type here, must be same or covariant return type. Okay, so return type, there's a slight change here. May have access modifier, different access modifier, may have less restrictive access modifier. Okay, may throw different exception, may throw narrow or checked exception. So there are slight changes here, but in a nutshell, whenever you are doing this overriding, that means whatever is there in the parent, the signature of the method, it should be same as in the child class with small changes. If you see compile time polymorphism, multiple functionality with same method name in the same class, custom implementation of a method from parent class. So here, slightly different thing is you can have multiple functionality, like you can pass 1 parameter, 2 parameter, 3 parameter. Here it is basically custom implementation. So basically between parent and child, or let's say interface to class or class to class. Now here it is compile time. Why? Because compiler knows about the method signature during the compilation time, and here compiler does not know about the method signature, and the linking happens to what particular method to be called from which class happens at runtime. So that is why it is runtime polymorphism. Now, interesting question: Is it possible to override an overloaded method in the child class? Yes, it is possible. Why? Because first you override it and then you overload it. So that is possible. The answer to this question is yes. Okay, so let's see the subsequent topics in the next sessions. Thank you.